2024 paper 2 question 14, we have a rhombus WXYZ with a diagonal ZX. ZW, Z going to W, represents a vector A, and ZX is a vector B. Express WX in terms of A and B, where A and B are the vectors. So pause if you want to have a go at it, otherwise I will continue. So we don't know WX directly, but we can take a different pathway, and the idea with these vectors is it does not matter which path we use as long as we get from W to X, and the direction of a vector matters. If the vector says WX, it's going from W to X. If it said XW, it's going from X to W. So WX, we can go from W to Z, then Z to X. So we add those vectors together. So the vector W to Z and Z to X. I will say this again, watch the direction of the arrows. That bit is really important. So WZ is the first one, but you notice that A is ZW. But the idea with vectors is if you change the direction, then the length, the magnitude is the same, but the direction changes. So going from ZW to WZ, we can say that WZ equals negative ZW. They have the same magnitude, the same length, but in opposite directions. Plus ZX. Now ZW in that direction is A, so we put minus A, and we want to underline the A to show it's a vector, and ZX is B, again underlined, and that's us finished section A. Now on to section B. M is the midpoint of XY. Express WM in terms of A and B. Give your answer in its simplest form. So this one's a bit more difficult, and you should pause the video if you want to have a go at it. I will continue now. So in order to find WM, we know that WX is minus A plus B, but if we go from X to M, then we go W to X and X to M. So we found that W to X is this, so it does not matter if we go this way or if we go this way, because both of those paths correspond to minus A plus B. So we then just have to find XM and then add it to minus A plus B. we have to also make sure that we write the final answer in terms of A and B and only A and B. So we can't have any other vectors involved. It's just in terms of A and B. If you have a look, because it's a rhombus, ZW and YX are parallel. And if two vectors are parallel and they have the same length, so if the lines are parallel and the lengths are the same, those two vectors must be the same. So in this case, we can say that ZW is actually equal to YX. And we then know that if ZW is A, or this, then YX must also be equal to that vector A. So what we can then write is we're adding the vectors. We're going W to M has to be W to X plus XM. So WX plus XM. But XM is 1/2 of XY because M is the midpoint of XY. So the direction of XY is the same as XM, but XM has only half the magnitude. So we can say that WX plus 1/2 of XY and ZW equals minus XY, which equals A. So XY equals minus A. You see the direction going opposite. So we have then WM equals minus A plus B plus 1/2 of XY. So plus 1/2 of minus A is minus 1/2 A. Now collecting like terms, so if we treat the vectors as like terms, minus 1 minus 1/2, that's minus 3 over 2A plus B and that's us done. Let's have a look at how the SQA gave the marks out in this question. So this one is a pretty open and shut case. It's minus A plus B. You either got it or you didn't. There was not much room for negotiation with that one. So this one, you got 2 marks in this one. The first mark would be for getting a valid pathway. So getting this would be a mark, and for getting the final answer would also be a mark. And to get the first mark in section B, they call it mark 2, but it's the first mark in section B. Getting wx plus xm on its own wasn't enough. You had to actually show that xm is half of the magnitude of xy. So we have some commonly observed responses. And if you got the first part wrong, then as long as you plug in the answer that you gave in the first part, if you then plug it in at this point, so we plugged in minus a plus b that we obtained from this. If you plug it in, and as long as you don't make the rest of the question easier for yourself, then you should be able to gain follow through marks. So I hope you found this video useful, and best of luck with the studying. If you have any issues, just leave a comment, but thanks for watching.